Here is a question that has kept me awake at night. You take one tiny electron and you fire it at a wall with two holes cut into it. Just one electron, a single indivisible speck of matter, and yet somehow that electron behaves as if it goes through both holes at the same time. Both at the same time. Now you might think I am joking. I am not. This is not philosophy. This is not science fiction. This is what nature actually does. And nature does not care whether you like it or not. By the end of our time together, you will understand exactly what happens in this experiment. You will understand why it matters, and you will understand why I have called this the only real mystery of quantum mechanics. Everything else you hear about cats and boxes, particles talking across space, all of it comes back to this one simple setup. Two holes, a source, a screen. Let's begin with something you already know. Waves. You have seen waves. You go to a pond, you drop a pebble into the water, ripples spread out in circles. Now drop two pebbles close together. The ripples overlap. Where two crests meet, you get a bigger crest. Where a crest meets a trough, they cancel out. Still water. This behavior is called interference. It is what waves do, always. Now let us think about something very different. Bullets. Imagine a machine gun, not a very accurate one, spraying bullets everywhere. I put a wall in front of it with two narrow slits. Behind the wall, I place a wooden board. I fire many bullets. Some go through the left slit. Some go through the right slit. Most hit the wall. When I look at the board, I see two piles of holes. One pile behind the left slit, one pile behind the right slit. Nothing mysterious. Each bullet goes through one slit or the other. Never both. Particles behave like particles. So now we have two pictures. Waves make interference patterns. Particles make simple pile-ups. Good. Hold on to that. Now let us talk about light. In the early 1800s, Thomas Young performed a famous experiment. He passed sunlight through a tiny hole to make it coherent. Then through two slits. On the wall behind the slits, he saw bright and dark stripes, an interference pattern, just like water waves. This shocked people. Newton believed light was made of particles. Young's experiment seemed to settle the debate. Light is a wave. Case closed, or so everyone thought. Then the 20th century arrived. We learned something new. Light does not arrive as a smooth wave. It arrives in little packets, clicks, one spot at a time. Albert Einstein explained this with the photoelectric effect. He won the Nobel Prize for that, not for relativity. We call these packets photons. So now we have a problem. Is light a wave or is it a particle? The answer is yes. I know that sounds ridiculous. Stay with me. We do something clever. We make the light very dim. So dim that only one photon passes through the experiment at a time. One photon, click, one spot, always one spot. It arrives like a particle. But we wait. We let many photons pass one at a time. We record every click. Slowly, a pattern appears. Bright bands, dark bands, an interference pattern. Think about that. There is only one photon in the experiment at any moment. It is not interfering with other photons. And yet the pattern looks exactly like a wave pattern, as if each photon interferes with itself. As if each photon goes through both slits. Now you might say, okay, maybe light is special. Fair enough. So let us talk about electrons. Electrons have mass. They have charge. They are matter. Physicists perform the same experiment with electrons. One electron at a time. Each electron hits the screen as a single dot, a particle. But after many electrons, the dots form an interference pattern. The electron behaves as if it goes through both slits at the same time. This is not poetry. This is what the experiments show. Now here is the key idea. Before the electron reaches the slits, the question, which slit did it go through, has no answer. It is not that we do not know. The answer does not exist yet. The electron is in a superposition. Both possibilities exist together. After the slits, something spreads out, something that goes through both paths. We describe this with a wave function. The wave function is not the electron. It is mathematics. It tells us probabilities. Where the waves add up, the probability is high. Where they cancel, the probability is low. That is why we see stripes. But when the electron hits the screen, it always appears in one place. Click. Never half an electron here and there. Now, let us ask a dangerous question. If the electron goes through both slits, why do we never catch it doing that? We try. We put detectors at the slits, devices that tell us which slit the electron goes through. What happens? The interference pattern disappears. Gone. The screen now shows two simple piles, just like bullets. By measuring the path, we destroy the interference. This has nothing to do with consciousness. The electron does not care if you are watching. What matters is information. If information exists anywhere about which path the electron took, the interference disappears, even if no human ever looks at it. To get that information, you must interact with the electron. That interaction disturbs it. This is the uncertainty principle. You cannot know the path without destroying the pattern. This is not a technical problem. It is a law of nature. Now let me make it even stranger. Suppose we mark the paths. Left slit blue, right slit red. We do not look at the color. No interference. Because the information exists. But suppose we erase the marks before the electron hits the screen. Now it is impossible to know the path. The interference comes back. This is called the quantum eraser. It does not mean the future changes the past. It means the electron does not commit until the final measurement. Now let me be clear. The electron is not a tiny ball. It does not split. It is not a classical wave either. When unmeasured, it is described by a wave function. When measured, it appears as a particle. Quantum mechanics has no classical picture. You must follow the mathematics, and the mathematics works. Quantum mechanics makes the most accurate predictions in all of physics. The mystery appears only when we ask what is really happening between measurements, and the honest answer is we do not know. There are interpretations. Copenhagen says the wave function is just a tool. Many worlds says all possibilities happen. Pilot wave says the particle is guided by a wave. Physicists disagree. All interpretations predict the same results. The mystery remains. Why does this matter? Because modern technology depends on this. Computers, lasers, transistors, because determinism is dead. The universe is not a clockwork machine. And because observation is not passive, looking changes reality. Nature keeps her options open until the last possible moment. That is unsettling, but it is also beautiful. Nature is not obligated to make sense to us. We evolved to survive, not to understand electrons. So if quantum mechanics feels strange, good, you are understanding it. Bohr said anyone who is not shocked has not understood it. Einstein never accepted it fully, and yet it works. So here is my question for you. When that single electron goes through the slits, what do you think is really happening? Is it a wave, a particle? Both, neither. Leave your answer in the comments, because even after all these years, I am not sure I know the answer. Before we end, I want to say something simple. Thank you for spending your time here. Time is the only thing you never get back. So the fact that you chose to spend it thinking about electrons and reality means a lot. If this experiment surprised you, good. If it confused you, even better. Confusion is often the first step toward understanding. Now I want to hear from you. What part of this did you find the most interesting? Was it the idea of superposition, the role of information, or the fact that nature refuses to give us simple answers? Tell me in the comments, and tell me something else. What topics would you like to explore next? More quantum physics, time, reality, consciousness, or the strange ideas that sit at the edge of what we know? This channel is about curiosity, about slowing down, thinking carefully, and not being afraid to say, "I don't know yet." If you enjoyed this kind of explanation and you want more like it, consider subscribing. It helps the channel grow. It helps more people find these ideas, and it tells me that this kind of content is worth making. Thank you for watching, and remember, nature does not owe us intuition, but if we are patient and honest, it will tell us how things really work. I'll see you in the next one.